This video addresses the nature and process of science and includes the topics pattern, process, theory, and law. The learning objectives include be able to identify and distinguish patterns and processes in the natural world and connect these ideas to scientific laws and theories. Be able to differentiate everyday and scientific definitions of theories, laws, hypotheses, and facts. And be able to identify and correct common misconceptions about science and how it works. To begin this module, see if you can answer the following question. Select all of the true statements. After theories become well supported, they typically become laws. Theories may include facts, laws, inferences, and tested hypotheses. Theories are tentative explanations that lack well-established evidence. Theories change more than facts. And theories explain patterns in the natural world. You can pause the video and think about these particular statements. Okay, let's see how you're doing before we begin the module. It turns out that there's only two correct ideas listed here. Theories may include facts, laws, inferences, and tested hypotheses, and theories explain patterns in the natural world. At the end of this module, you should be able to get these questions correct, as well as many others dealing with this topic. So pattern and process are very common in science. Let's look at a particular example. We could combine two clear liquids, and when we observe the combination, we see that a white precipitate forms at the bottom. Well, we know that the two liquids came together and a white precipitate formed. That's clearly observable. But why did this happen? What caused this particular reaction? A pattern is simply describing the observable events. All areas of science include patterns and processes. Patterns typically include the what, and processes include the how or why, that is, the causes of a pattern. We typically cannot observe processes, but we can observe patterns. We can see the world, we can note differences in the world, but explaining them is a different matter altogether. Let's think of two examples, one from medicine and one from chemistry. We know that the initial pattern, that is repeated observations, showed that people were getting sick. We knew people get sick for thousands of years, and today we can see people getting sick all the time. The question is, why are people getting sick? What is the cause of the pattern? For example, it could be getting a cold, that is, having a viral infection. So the observable pattern is something we're actually quite familiar with. But how do we exactly figure out what the cause of that particular pattern is? Let's give an example from chemistry. Chemists have known, long before the modern discipline developed, that certain combinations of materials in the world produce particular reactions. That is, they got different products. But it took a long time before chemists understood why those particular combinations were causing particular outcomes. Well, let's look at a particular example in this case. We can see, for example, that plants wilt. If we don't water plants, they have a very characteristic pattern, and this can happen again and again. We can add water, we can take it away, and wilting will continually occur. So most of us are very familiar with this, and this seems quite obvious. But if I were to ask you, can you explain the mechanisms or processes that cause a particular plant to wilt? This is a very different task. It's very different because we cannot see the mechanism that's causing the pattern. Now let's look at some other biological examples. Let's say we look at some small fruit flies under the microscope, and we note they have a series of different sizes and shapes. Well, what processes, or maybe it's only one process, accounts for the differences between these fruit flies? You can see they have different eye colors, wing shapes, and different bristles. What causes those differences? That's what process is all about. Here's a perhaps more interesting example. It's a map of the world, of course, and you can see that what we're showing are the blood types for the human species. Take a look at the light blue. Why is it that in South America, for example, the O blood type is so incredibly common, while that's not the case in other places on Earth? That is, we can document blood type patterns, but how would we go about explaining this? Well, we can summarize what we've been talking about so far as patterns, which are the what of nature, based on observation, senses like sight, sound, smell, touch. And patterns are observations that occur with some regularity, that is, we see them again and again. In contrast, a process is an explanation, it's an accounting for how or why something happens. A process is typically based on inference, logic, deduction, and many other factors we'll be talking about. It's unobservable. We can't directly see the process. And a process accounts for the patterns. Okay, so pattern and process seem somewhat straightforward. Most of us have heard the words law and theory. Let's add laws and theories into our discussion. So what is the connection between patterns, processes, laws, and theories? Well, laws typically refer to repeated patterns that occur with some regularities. Laws can be called cookbook science or the rules. For example, let's say that you want to bake a delicious cake. Well, you follow the cookbook. You add the eggs, the flour, the sugar, you put it in the oven for the particular amount of time, and out comes a delicious cake. But why exactly did those combinations of ingredients come to produce this thing called a cake? So the cookbook merely describes what to do. It does not explain why those things happened. So theories, on the other hand, are very similar to processes. They are the explanations for how and perhaps why something happens. So theories are explanations, and laws are descriptions of regularity within nature. Now, the cooking example was a little far afield from biology. So let's talk about two particular examples you're probably familiar with. One of them is Mendels Laws. So you may remember Gregor Mendel, the monk, who developed some repeated observations about what happens with heredity. He described patterns of inheritance. That is, we use Mendel's laws to predict what might occur. But Mendel's laws don't really explain why the particular patterns occur. They are simply generalizations of pattern. On the other hand, you've probably heard of Charles Darwin and his theory of natural selection. This theory is a process because it's an attempt to explain why life changes through time. That is, it's not a documentation that life does change. For example, we all know that every year vaccinations are needed because the cold virus is different from the previous year, not to mention the flu and many, many other types of pathogens. Well, we have an observation that life changes. What Darwin was trying to explain is why or how it changes. And so his theory of natural selection was the explanation. So here we contrast Mendel's laws with Darwin's theories, and we can see the similarity between patterns and processes. Now, it's important to point out that a common misconception or inaccurate idea among many students is that theories become laws, and this is false. Theories never become laws. Laws are consistent patterns, and theories are explanations. It's really hard for a pattern to become a process or a law to become a theory because they're fundamentally different things. They are trying to account for different aspects of the natural world. The problem is, in everyday life, on television, and the movies, you're going to hear the word theory quite a bit. It's applied very loosely and in many cases quite sloppily to apply to any kind of tentative explanation. But that's not how it works in science. It's important to distinguish between everyday uses of the word theory and scientific uses of the word theory. Theories are explanations, and they're some of the most valued components of science. As a scientist, the greatest achievement that I could ever hope to achieve would be developing a new theory. Now, What I mean by that is, this isn't simply a guess or some hunch that I have. It would be a very rigorously established explanation for an aspect of the natural world. Well, because of this confusion between everyday language and scientific language, the National Academy of Sciences, which is the most prestigious group of scientists in the United States, actually tried to define theory. And here's what they said. A theory in science is a well-established explanation of some aspect of the natural world that can incorporate facts, laws, inferences, and tested hypotheses. One of the key points here is a theory is defined by its explanatory power, that is, what it accounts for in the world. And a theory is something quite complicated. It's not something simple. It's an amalgamation of many ideas. Here's a visualization that may help make sense of this. On the right, you can see that an explanation is encompassed by many different features on the left, such as facts, laws, inferences, and tested hypotheses. The order, the articulation, the assembly of these ideas together in a logical way helps to build what we call a theory. So a theory is a complex structure that tries to explain something in the same way that if you had to explain something about practically anything in the world, you would need to bring together a whole bunch of different ideas. Patterns. So again, patterns relate to observations, facts, and laws. On the other hand, inferences, explanations, and theories relate to processes. They're unobservable, and they explain how or why something occurs. Let's go back then to the case of this wilting plant. We can observe the leaves falling, the lack of water, again and again. But what we want to be able to do as scientists, and a goal of science, is to explain what exactly is happening when this plant wilts. Why does this occur? Well, in order to answer that question, we're going to have to go into the unobservable world, the world that we cannot see. And in order to do this, we're going to have to engage in the concept of models. So, today we've talked about the nature and process of science, in particular the ideas of pattern, process, theory, and law. At this point, you should be able to identify and distinguish patterns and processes, given any type of example in biology, chemistry, or just daily life. You should be able to connect these ideas to scientific meanings of the terms laws and theories. You should also be able to differentiate everyday and scientific definitions of hypotheses and facts. And you should be able to identify and correct some common misconceptions about theories. So going back to the question we posed at the beginning of the lecture, make sure that you are able to distinguish these many components of the nature of science.